rows? 2 by 5. Careful. Rows by columns. Remember, you can do this number. Okay. Rows by columns. Next. Number 2 is a scalar multiplication situation because it's telling me to take matrix B and it's telling me to basically double it. So who would like to share their new matrix with me once it has been doubled? Don't all volunteer at once. I don't know who to call on. Okay, go ahead. Thank you, Catherine.
20, -4, 1, 6, 4.
Perfect. So you're just literally multiplying it in. You're taking your 2. You're doubling every entry that's in there. For problems like number 3, remember we can't add and subtract matrices unless they are the same dimensions. Are A and C the same dimensions? Yes, they are both what?
3 by 2.
3 by 2. Careful, some of you are giving them to me backwards, so make sure you remember it's rows by columns. And it almost throws me because I feel like a lot of stuff in math is alphabetical order, so it feels like the columns should come first, but they don't. It's the opposite of what you would think. Okay, listening. So you're legitimately going to subtract in the order they tell you to. So take A and take the entries that match up and subtract them. So -1 minus 0, -1. 0 take away 3, -3. 8 take away 8, 0. 5 take away 9, -4. 4 take away 2, 2. 2 take away -2, +4. Be careful of your signs and make sure that you're doing okay with them.
Wait, so it has to be the exact same.
To add and subtract matrices. It doesn't matter what dimensions you have here because you're just literally doing the scalar multiplication where you're kind of, for lack of a better word, distributing the 2 in. Okay, for number 4, matrix A, -1, 8, and 4, 0, 5, 2. Okay, can we calm it down? Give me a couple more minutes of your time, please. Okay. Okay. Oh my. Alright. Yeah, let's later, let's not draw portraits of each other right now. That's great. Okay. Okay. Here we go. Listening, please. At first glance, you look at it and you're like, I can't multiply that. What is this one in terms of its dimensions? 3 by 2. What's this one? Okay, so remember that these have to match the inner dimensions. Do they? Yes. And my resulting matrix is going to be a 3 by 3. Now, remember that I like to do 2 steps so I can make sure I get it right and do a little bit less in my head. Okay? So I'm going to circle my rows by my columns. So the same way you find dimensions is the same way you multiply. Okay? Listening. Listening. Okay, here we go. -10 plus 0 is just -10. 2 and 0 is just 2. -0.5 and 0, so this will be just -0.5. So that one I really probably didn't need to do 2 steps on, but the other lines are a little bit trickier, not much though. So here I have 80 plus 15. Here I have -16 plus 10. Here I have 4 plus 50. And so for that row, I will get 95, -6, and 54. Are we matching up so far? Perfect. 40 plus 6, so 46. -8 plus 4. And then 2 plus 20. So 46, negative 4, 22. Now remember, unlike the exam, we've kind of moved back into the realm of like, you need to show me your work for full credit. I don't necessarily need this step, so you won't be penalized if it's not there. So if you are really good at mental math and you're like, I can go straight from there to there, that's fine. You don't need to have this middle in between step. Question?
So would you just need to add the two matrices and show that you're multiplying the two together?
Yep. I would say be careful though, because remember, when I can't give you partial credit, there's a potential to lose points if you do too much in your head and you do it wrong. That would be my only like little warning. Okay, flip to the back. The top one wants me to find the inverse. Remember, sometimes inverses exist, sometimes they don't. It depends. And that is because the scalar multiple that multiplies in to help us get the inverse matrix has a fraction. And if the denominator of that fraction is 0, that's problematic. And that's when the inverse doesn't exist, because we can't have 0 in the denominator. Remember that we multiply across like this, negative 9, and then it's minus negative 10. Be careful with your sign. So what fraction do I really have up front being scalar multiplied in? 1. So is that going to do anything? Nope, not exciting. Alright, so let's make the matrix that lives here. So remember, these two switch places. So my 3 and my negative 3 flip-flop. These two on the other diagonal switch signs, so this becomes positive 5 and negative 2. And if I multiply by 1, it's just going to stay the same. So this would be my final answer, because multiplying by 1 is not going to change anything. Are we good with that? Okay. Alright. Next, we want to first convert into a matrix, and then we want to solve, kind of like we did on Friday. And hopefully those trophies are displayed. My winner, you need your trophies displayed while at home. That's my only request. Alright, so let's make our 3 matrices. So you should get 3 matrices when you kind of tease this apart a little bit. So the first matrix should be your coefficient matrix for the variables. So take them out exactly as you see them. The second matrix is the variable matrix. The third is what it's equal to. I've been calling it the solution matrix. Notice that if you were to multiply it back out, you would get back the equations that you started with. And also there are problems of both types. You need to be able to go from this form to this form and this form backwards to this form. So make sure you can do both. And it says that on the bottom as well. Okay, so we want to figure out what x and y equal, which means we need to find the inverse of this, so we can multiply it to each side so we can solve. So we need to go ahead and find our inverse. It's 1 over 27 minus 28. And then remember how we construct this matrix. These two flip, 9 and 3. No, you're not getting a formula sheet. No, there's no note card, right? Like we've had some other helps along the way. Remember, those don't exist for this test. You need to make sure you're ready walking in. These on this diagonal flip signs. What is this fraction out front going to end up being? Negative 1. So when I go ahead and multiply that in, negative 9, 4, 7, negative 3. And then what do I need to do with that inverse matrix?
Multiply by negative 1.
Yeah, each side, right? It's just like any other equation. We have a balance here, and if we don't keep that balance, that's a problem. So we need to multiply it to both sides. Okay, on this side, remember the way that we construct the inverse is so that when you multiply these together, they give you the identity. Remember, your identity matrix is going to have 1s on this diagonal and everything else is 0s. So the 1s always live on this diagonal, everything else is going to be 0s. That's what your identity matrix looks like. So that's kind of going to this question, what does the identity matrix look like? again, one's on the diagonal that goes top left to bottom right, and then the rest are zeros, and they only exist in square matrices. So you'd have to have a 3x3, a 4x4, so on. Okay. Here's my XY. So this is basically like me saying 1x, 1y equals. Over here, I need to actually multiply this out to figure out what x and y equal. Rows by columns. Negative 90 plus 80. And then 70 minus 60. So up here I get negative 10, and then I get a positive 10 for the other. So x is equal to negative 10, y is equal to positive 10. Final answer. How do we feel about that one, okay? Because I know those are the ones that we were correcting a little bit when we were working on them the end of last week. Now granted, those numbers were weird too. That's what happens when you see a worksheet off the picture. Sometimes they have decimals when you don't expect it. Alright, so I'm going to post that